don't be afraid to apply it to build something, because that's what I've seen. I've seen a lot of small groups, people just take an idea and just run with it. And APL really holds your hand the whole way when you need to build something amazing.
Welcome to another episode of ArrayCast. I'm your host, Connor, and today with me I have my three panelists, Adam, Stephen, and Bob. We're going to go around and do brief introductions, and then we have a couple announcements, and after that we will hop into an interview with our first-time guest.
And I'll start things off. I'm Bob Terrio. I am a J programmer. I am a J enthusiast, I guess, because I'm actually not employed by J. But I am working on the J Wiki, and we may have some announcements coming up on that because we're making some progress, and it's wonderful.
I'm Stephen Taylor. I'm an APLer from way back and currently the KX librarian.
I'm Adám Brudzewsky, full-time APL programmer at Dado Wiki Limited.
And as mentioned before, my name's Connor. I'm a professional C++ developer, but array language enthusiast and combinator enthusiast at large, as many of our regular listeners will know. So we will throw it to Adam for a couple announcements, and then I'll come back to me for one more.
Okay, so first off, the APL Seeds second installment, which is a kind of conference meeting get-together a day. It's going to be the Tuesday, the 29th of March, and it is geared for people who are interested in array programming, APL in particular, to get some view and meet some people that do APL and get some introductions to that. So that's going to be really exciting. Looking forward to that. Furthermore, I have started a weekly event in the APL Orchard, so APL Orchard chat room, part of Stack Exchange. And there we take every week on Friday a problem from a past APL programming problem solving competition, and people submit their answers to that, and then we discuss it a bit and see how we can optimize it and variations on it. And it's kind of lively. And then a follow-up video based on people's submissions is then published in the week after that until the next one. So it's a really nice thing to join. You can find the previous chat logs, and of course the videos are there, and links to all of this, of course, APL Seeds as well, in the show notes.
Awesome. And I think before I mention my announcement, it's worth noting about the Apple Seeds or APL Seeds conference. This is the second edition of it. So the first one was last year in 2021. So I think we can throw in the show notes links to all of the recorded talks. I gave a short talk there. I think Rodrigo, our guest from 2 episodes ago, also gave a talk there. And so yeah, if you're not able to attend the conference in person, all of the talks will be recorded. And I think most of them are about 20 to 30 minutes long. So they're not like 90 minutes. They're easily digestible at sort of a lunch if you still take those during the pandemic times. And also too, I'm not sure, maybe I missed this, but it's worth noting again that it's at least I think, I mean, Adam will correct me, it's a completely free conference, correct?
Yeah, it's free, but you do need to register, and the link for the registration will be in the either in the show notes or on the site that we'll link to.
Okay, yeah. So it's just worth noting, because a lot of even single day or 2 day conferences these days, they'll either have a small fee or sometimes a non-small fee. But yeah, as this is targeted at beginners, potentially if you're a listener to this podcast, you already are familiar with the languages. But if you know folks that are getting started with computer science, it's potentially worth sharing that, like, hey, have you been interested in this new kind of paradigm? Because it's geared towards beginners and people that might be looking to get into the language. So I think it's a great sort of resource for people that are maybe new paradigm curious but have never sort of dipped their toes in yet. With all that being said, my short announcement is that I was on the APL Farm Discord, which is a collection of all the different array languages, and recently just happened to stumble across an announcement update of a site called BQNPad, which is basically like a tryapl.org, but for BQN. And it is super awesome. It's got syntax highlighting, which the current BQN language JavaScript REPL that is hosted on sort of the documentation site that Marshall Lochbaum's done, they don't have syntax highlighting. So it's sort of just, it's a nicer look. But also, too, a really cool feature that they have is they have like a preview result of the expression that you're currently building up, which I don't think exists on any of the other sort of online REPLs. So while you're currently typing, typically the way you work in a REPL is you hit enter and then you get the result and then you build it up slowly. But in BQNPad, you can just type the expression, and every single time you type a character, it sort of reevaluates it. So sometimes it'll give you little errors while you're adding, one of two symbols that you need to add to sort of get the next state of your expression. But anyways, super neat. I believe it's being developed by, I might get this wrong, so I apologize, Andre Pop. So kudos to that individual for working on this. And I think this is similar to the announcement that Bob made, a couple weeks ago, that Jay is working on getting something like this up and running. So we'll have announcements about that in the future when that's ready to go. All of that out of the way, it is now time to introduce, as I mentioned before, a first-time guest, Josh David. This is going to be a pretty exciting conversation with Josh. Josh was exposed to Dialog APL during an internship with the Carlisle Group, which I believe is headed by Paul Mansour. He can correct me if I'm wrong, who is, I think, pretty well known in the APL/array language community. He continued with APL and was a grand prize winner in the 2016 APL problem-solving competition, which I believe means that there should be, if you attended the conference, there should or might be a video of sort of going through how he won the contest. And he's a recent graduate from the University of Scranton with a degree in computer science, and he now primarily serves as an APL consultant to North American clients and works on APL tools. So I will say welcome to the podcast, Josh, and maybe if you want to start off, confirm or deny whether there is a talk that exists of you walking through how you won that contest. And if you want, feel free to, jump back to, how you started in computer science / how you, ended up in the APL/array language world.
Yeah, thanks, Connor. There is a talk on YouTube for my presentation for the problem solving contest. So maybe we could put a link for that somewhere. But yeah, so thanks for inviting me on. It's really exciting. It's really exciting to see you and Bob and other panelists put in the effort to produce these podcasts. It's kind of like a new revolution of information. We had books and now podcasts are just exploding. Really interesting and happy to be a part of one. So my name is Josh David, 24 years old, and I write APL code for a living. Was born and raised in Scranton, Pennsylvania. So you might have some listeners who are familiar with the sitcom The Office. That's the city and where it's based from. And yeah, it's a real place. So there's actually quite a bit of history in that city with APL. So the last APL conference, wasn't exclusively an APL conference. It was all array languages of the millennia in 1999 was held in Scranton, PA. There were a couple of J presentations as well there. And Ken Iverson himself was at this conference. So I was only 2 years old at the time, so I didn't attend it. Not all of us have a track record of showing up to conferences at the age of 1, like Adam. So, yeah. But this conference was held at the University of Scranton, and it was, one of the organizers was Dr. Stephen Mansour. So he taught statistics there, and actually his brother was my neighbor, Paul Mansour, growing up.
Oh, wow.
So that was how I got introduced to APL at a young age. He was actually my neighbor, and he's well known in the APL community. He has his own small company that has, less than a handful of APL developers managed to create an industry standard software for financial managers. So that was my first introduction, and I got to do some internships with him over my summer breaks in high school, and that was my introduction to APL. And I always knew I wanted to get into programming at a young age because I really liked building things and seeing a tangible result. So, from Legos as a kid to it just gives you this freedom to kind of do what you want. You have an idea in your head, and then I want to express that to the computer and, get an executable or something that has the full stack. And so then I continued looking into other programming languages as well. High school, I attended a computer club where in the introduction class, I remember the first one, we were learning about Java. It was probably going over a Hello World program or something. And then I remember seeing the words public static void main. And my first question to the instructor was, well, what is that? Why do we need it? What does it mean? And the response I got was, oh, well, just ignore that. We just need that all the time. And you don't have to pay attention to it. And that kind of didn't sit right with me. And, having experienced APL before this, that was kind of left a bad taste in my mouth, but I continued to explore it and then went on into college to get my bachelor's in computer science and do some internships with other companies that, don't use APL. So just traditional Java-like languages and so on. And then, as you mentioned, I participated in the problem-solving competitions and got second place. And then in 2015, and then the next year, I got the grand prize in the general computing category. So then I really got more involved with the APL community at the conferences. And then by the time I graduated, my plan was, take the traditional CS approach of pick up Cracking the Coding interview book, practice some leak code problems. And I was headed that way. And then I decided to reach out to the APL community again, see if there was any openings. And sure enough, they were starting a consulting business for North American clients. And I decided to hop in on that. And that's what I've been doing since I graduated about a little less than 3 years ago. And from then, I've been programming and writing APL in production environments as my 9-to-5 job.
Wow. So that's pretty crazy that you just had a neighbor that was sort of a prolific individual. And that's I feel like that, what percentage of people had a parent like Adam or a neighbor like Josh, or just like the proximity to someone who was sort of and Stephen, do you also have what was you raised your hand? Do you have an origin story that your basement suite or something?
Okay, well, I actually got a question for Josh here. I've got huge respect for Paul Mansour as an application developer, and I'm wondering, it's too general a question to ask. What did Paul teach you? It's like, well, probably the answer to that seems like everything. But I'm guessing that in teaching you APL, he probably insisted on certain ways of writing and made a point of it, because he's a very thoughtful, principled developer. And I wonder if you could share any of what you consider the main lessons that Paul taught you.
Yeah, that's a good question. And actually, you're right on with that assessment there. He's very big on coding styles, which is probably one of the biggest things I've learned there. And he has recommended ways to write APL programs in these production environments. It's on there's the Dado GitHub repository in the wiki. There's a link on that. And there's a lot of principles taken from the Clean Code book, which is famous in programming circles. So that was one thing, because traditionally APLers, and I see this a lot too, the traditional APLer is not a programmer, so they don't have a lot of, it's kind of the double-edged sword of APL. You have one of the strengths of it is that you have the subject matter expert, the domain expert, someone who's not a programmer, maybe a chemist or an actuary writing code. So they're not familiar with some programming principles, and then it can, you can fall into technical debt of having harder to maintain code. So having these principles in APL, it's somewhat unorthodox because APL lets you do whatever you want. And some of these principles in particular, when I got what one I like in particular is keeping functions at the same level of abstraction. And if one thing is, if your code needs comments, it's not clear enough, your function name should be clearly defined to say exactly, what it does. So this way, even if your code's not clear inside the function, someone could easily rewrite it, because your functions are very small too, which is helpful too in source code environments when you avoid merge conflicts and so on. But having function at the same level of abstraction, so it's either mostly English, which is calls to other functions, sort of a functional approach, or it's mostly APL. And the other style is using defunds. The advantages of defunds is two of the hardest problems in programming is naming your variables. That's one of the hardest problems. So two of them are solved for you. You have alpha and omega, left and right argument, that's taken care of. You don't need to worry about that. And then the other interesting thing is alpha and omega, they're very short symbols. I used to write longer variable names, but the idea that he has is you keep short one-letter variable names. If your function's small enough, it's within scope and should be clear. And the other magical thing about that is you get to see the relationships between primitive functions more clearly, because the APL symbols are very short. So you can kind of get a very large scale view of the function and what's going on when you do that. So I've started to come back to that style of, making sure your code is more broken up, modular, and short. I mean, there's a whole lot to this. The other thing is he was very big on testing. That was a big part of my job, making sure you have proper tests for everything. And it has lasting effects on you when you try to do software testing. You're always thinking about edge cases of things and making sure things go, But that's also a very important part of software development, that the traditional APLer is not really expected to behave or participate in. So I was very happy to have that kind of foundation for learning about creating APL systems.
I have 100 questions. That's actually an order of magnitude less than the usual number of questions I have. So that's actually not good. I have 1,000 questions, like always, because I'm also here, and maybe it's right now I'm split between, clearly we have to have or try and get at least Paul Mansour. Is it Mansour or Mansour?
Mansour. Sorry. Yeah.
Mansour. We should clearly have Paul on the podcast to talk about the Carlisle Group, because they actually have like you mentioned, the GitHub repo, and I think actually Adam has mentioned this maybe in one of the dialogue webinars that happened recently. It might have come up about one of their sort of APL to Excel or vice versa, or some sort of format to APL and back and forth. But it looks like they have a bunch of stuff. So you mentioned Dado, DADO, and it has a ton of APL stuff. It looks like there's also a practical APL introduction to APL course. So clearly and everything is 100% APL. I guess because we will have Paul in the future, it's probably best to save most of those questions for him. But do you mind giving a brief summary? Because you mentioned that he was building, it sounded like their small company was building software tools for financial managers. Do you know how that business sort of started, and so is it sort of consulting on a one-off basis, or are they building software that the clients or managers are purchasing, or do you know much about that?
Yeah, so maybe he could explain the origins of that, but the software, their primary flagship software is the collateral analysis of CAS. It's known as CAS and is used across pretty much all these major banks across the world. Use it to do some analysis and reporting. He also has another product which I worked on called FlipDB, which is a relational database management system and also entirely written in APL. So his applications, that's the other thing, his applications are entirely pretty much back-end, front-end APL. And which is why having this experience and other experience too, it kind of drives me nuts when I hear people say, oh, APL, yeah, you could write snazzy one-liners with it, but you can't write production code with it. So with my experience growing up, and I see this work, and I've seen people, very small teams, blow the competition out of the water just with pure APL. There's a difference between these one-liners and production quality code, but you probably shouldn't be doing the latter without understanding the former. And there's some nuance to that I could get into. But to go back to your question, I'm really happy that, with this, there's been a sort of a push recently, really spearheaded. I can't think of too many other APL companies that are doing this open source library push as much as they have. They have very useful libraries that I use in my day-to-day work. I got to do a presentation on Dado, Dialog APL Development Operations, which is an interesting name too, because Dado is actually an architectural piece on a wall. It's the base of a wall. So it kind of, the idea is to base your APL applications on a solid foundation, which is a whole interesting topic to discuss, is workflow in Dialog APL. And especially with, now we have things like Git. These are very powerful tools. And the whole idea of APL is to have a tool of thought to express your ideas at the speed of thought. And it's hard to do that now with the modern constraints like version control. How do I version an application? Things like this that just go back to so his library goes back to the core of, I want to work in APL fast. I don't want to have to deal about that. I want my framework to take care of things like that. So these kind of discussions are things that you have to start having when you start using APL in production environments, that, if you're just solving a code golf challenge, you don't really care about this, but there's layers to it.
So I think we should definitely hop back to the one-liners versus production code. But I know, Bob, you had, I think, wanted to ask a question.
Yeah, it was kind of related to that, because as an APL programmer, you do have a different time frame, I suppose, when you're working on a problem compared to most of the other programmers who might be working in other languages. How do you interact within a larger venue? How do you interact with other programmers who might be working on a vastly different timescale than you are?
So by timescale, do you mean deadlines or?
Just the speed at which you can refactor and change your code and change your ideas. And when I was going to school, I heard stories of people who were sent out to work for a company, and they were given an assignment, and then they came back a half hour later and they were told, well, next time just take a couple of days, okay? Because this isn't working for us.
Yeah, that's true. It's interesting, working in other companies where APL isn't the only language that's used, but you can, you definitely, me having been on the other side of the circle too, as a Java programmer primarily, I've developed in other languages too. And even in college, when I would develop solutions, when I had to have problems, the first solution that would come to me was the array solution. So I would solve it in APL and then figure out how to write this in Java. So I started doing that a lot. And then eventually I realized I'll just cut the middleman and just write an APL, which is nice. The nice thing about working in production environments, well, there's an asterisk there, that people don't care what language you use. They just want to see the job get done. Ideally, that's how it should be. For a class, you might be required to submit a solution in a certain language, but in the real world, results are what matters. And you even see this a little bit with advent of code. It's kind of nice to see the advent of code. In the leaderboards, you'll see some APL solutions. Jay Fode used to be the CTO of Dialog, and he has some very nice repositories on GitHub showing him his solutions to these problems in APL. But yeah, I mean, there's definitely an advantage in using APL, especially Dialog APL in particular. There's a lot to it that you don't appreciate until you have a problem to solve, like interacting with the environment, whether it be database interactivity, reading from Excel, controlling Excel, all these things. You could just get data in, especially when the requirements change. It's having the REPL to interactively debug code, and just that playground there. And it really gets into the whole idea of the array-oriented program paradigm itself. It's not just APL. It's if I could say this without being put into a mental asylum, it's kind of the language itself kind of guides you or speaks a solution to you before you even get there. So that I think that's really an important part of solving problems in APL too. It's not just the speed at which you could do things and interact with the environment. It's that you come and look at problems in a different way that people in other languages might not see the problem, which is why so for some of these companies, I'm not even allowed to name them because APL gives them such a competitive advantage. They don't want that to be out there. And it's really, I've seen it create, there's applications where I've seen it create billion-dollar breakthroughs in a field just because of they structured their problem using an array-oriented style of thinking, and APL helped them to do that. Even now, some of these developers are not obligated to use APL. They can use Python or other languages. But my last meeting I had, I met someone who mentioned that, using these other languages is fine, but there's nothing like just a jot expression in APL. And for some of these when you get into these, the way APL handles structures, with rank and depth, it's very, very hard to recreate that in another language and deal with it in an orthogonal way, which I could talk about more, but I feel like I'm opening too many topics, so I'll pause.
Let me just jump in there for the listeners. And what Josh is saying, a dot expression, that's the outer product, which is kind of like a double for loop or double map, if you want. It's taking everything from one set of values and combining in every possible combination with everything from another set of values. Hence, even though it's obviously has high complexity, but if that's what your task requires, it's really neat to be able to do that in APL, and Jay has a similar thing.
Yeah, fun fact is, I think it was the very first episode of my other podcast, ADSP. My co-host and I, we talk about algorithms and finish by talking about our favorite algorithm. And most people up till then, if you'd watch my talks and stuff, know that I love inner product, or what's known as transform reduce or map fold in certain different languages, which exists in APL as a primitive. But that was my favorite algorithm up until I discovered outer product. And I absolutely just love, like, there's a problem, like a leak code problem, that's like given a string of LURDs, which stand for left, right, up, down. Figure out if you end up where you started, which is just a matter of tabulating how many lefts, ups, rights, and downs are there, and basically checking are the lefts and rights equal and the ups and downs. And you can do this kind of trick where you use an outer product where the left thing is a string of 4 characters, LURD, and the right argument is just your input string. And you can do basically like an equals, and it'll generate like a 4-row matrix where each row corresponds to the L's, the R's, the U's, and the D's, and then you can just do a plus sum on that matrix, and you immediately get the counts of the L's, the U's, the R's, and the D's. And like in any language, except for maybe like languages like Python that have like a counter thing, you need to call like 4 different countifs or like 4 different counts, and it's just like so noisy. And in APL, you can do it in like literally like 6 characters or 8 characters or something. So anyways, yes, outer product jot is amazing. It's one of my favorite. Is it still my favorite? Who knows? But it's definitely, it's very beautiful. We'll link to some docs somehow for those that want to check it out. And Haskell also has it. There's very few languages that have it, but Haskell does have an outer product algorithm if you are a Haskell programmer listening.
Marshall Lochbaum did a whole introduction at LambdaConf to APL, introduction to APL, all based around the outer product.
Oh yeah, I've seen that talk. That's a very good talk. Yeah, we can link that as well.
Now that you mentioned the inner product, outer product as your favorites, they were actually originally seen as kind of the same thing. That's why they use the same symbol in APL. And like the outer product was seen as kind of like a downgraded version of the inner product. It's like the inner product is a series of reductions over the outer product. So the outer product is like a partial result towards the inner product.
Interesting.
And eventually Iverson even generalized the outer product more as he called it the tie operator or adverb, where where you choose how many X's are being combined, or how many X's are being withheld from making all the combinations. So by default, it's the 0. So you combine everything, but you could also withhold certain X's like that.
Stephen?
Josh, you referred to a couple of roles now for the APL programmer, which may be unlike most people's experience of coding. So the first one's fairly familiar within the APL community, and that's the gun developer, the guy who will solve the problem faster with less code and will be running more efficiently than people working in the other brand X technology. I'll be around the corner on my second beer by the time you finish. The other role you referred to is people coding. Coding not being their main thing. They've got domain expertise and they can use APL to translate that into software. And of course, that's a role in which you don't learn a lot of computer science stuff. You're maybe not particularly into algorithms, except the particular algorithm you might need for your domain. You don't know a lot about DevOps and administering stuff and organizing code and so forth. You refer particularly to actuaries. I worked for years with an actuary who's done 20 years or more of developing an APL application and has learned what he needs to know. And so I guess my role in that was of a professional APL developer who can show him, well, was a day anyway, new techniques, and can introduce him to other technologies, things that are going on outside the APL world. That's something which, if you're a Java developer, as far as I know, that doesn't happen. Your interaction with the guy with the domain expertise comes in the form of specifications. So, as far as I know, I'm not a Java developer or a C# developer or a C++ developer. As far as I know, you're sitting in a room with a bunch of other developers. I wonder, Josh, what's been your experience of supporting other APL programmers as a professional programmer in that way?
Yeah, that is a big distinction between APL versus other languages. There's kind of now this push in IT organizations to silo out the application into very distinct parts. So you have a UX team, you have a UI team, you have other people, and you take persona interviews of them and try to figure out what the end user wants. And that's every time you introduce a step away from what the client wants, you have this sort of entropy and you lose information that way. There's always a loss of stuff. So that's why I think it is important for when you see an APLer develop an application, as the subject matter expert, they're the best person to know exactly how the user interface should flow, exactly how the user experience should be, where this button should be. And if you think about it, a lot of UI development is math-based, which I think is another reason why APL was good at this, because it's very easy to do math in APL. And so, yeah, I mean, I respect these other languages too. I know I have a lot of friends who develop in these other languages, but personally, I can't keep up with all the changing frameworks that, there's always a new one to learn. So I respect those who can juggle all those different frameworks and everything. But to me, I just want to focus on the problem more. And that's why, I just prefer to solve problems in APL.
Paul Mansour did a conference presentation years ago. I missed it, and I always wanted to catch up with him about it. I think the title of his presentation was something like "Why My Mother Has a Particular Plate, a special plate for serving corn on the cob, and I don't." And I understood that the subject of his talk was very much what you've been talking about today, about using APL as his only stack for doing everything. And I'm remembering now that in our last episode, Morten Kronberg called basically he called APLers Luddites. What I understood him to mean by that was that we're not chasing after every new technology. We're not chasing after is probably not the word I want. We're not spending a lot of time staying up to date. We've got a good language and we want to do as much as we can within it. So from his experience as an APL vendor, he's got users who wait very much for the APL vendor to provide access to the new technology and explain how everything can be done in a purely APL way. So with my huge respect for Paul, I'm kind of very interested in how he's been able to pursue this a single stack development.
Yeah, and it's interesting now because we're seeing a sort of shift, not a shift, but a new development in this front with people have been trying to come up with HTML solutions in APL for a while, and that's one of his latest projects called Abacus, is figuring out how to control an HTML front end from APL. And there's a lot of interesting things there. But, we are going to be reaching out to, we're not going to try to reinvent the wheel on HTML. It does a very good job at rendering things, CSS. So now the idea is, part of the APL's programming stack is going to have to, you're going to have to know some CSS. You're going to have to know a little bit of that. But the important thing is doing the callbacks. Instead of writing JavaScript, it would be better to have APL handle your user input, do your calculations. So that's the goal with the Abacus library, and it's still developing, and it's interesting to be a part of and see how that turns out.
I sort of want to jump back to, at one point, you mentioned the difference. I guess it sort of ties into what we were just talking about, is production code. But you said that, you could dive a little bit deeper on writing production code versus writing one-liners. And I think you said, you can't do one with the other. Yeah. I can't remember which one you said was there. But do you want to, delve into that a little bit? Because I definitely know that I get a lot of questions from, the social media verse of, me posting one-liners and doing videos of, one-liner solutions. Because those, to be honest, it's the easiest 10-minute videos to make, is a leak code problem that is solvable in 4 characters. And first you show a Python, a Haskell, or whatever, and then you go boom, and and then everyone says, okay, that's pretty cool. But can you write a non-trivial application? And I bet that's a lot more painful as soon as you have to do IO and stuff. So yeah, feel free to share your thoughts and experience in the comparison between those two.
Yeah. So when you talk about a one-liner, there's there's a lot of different types of one-liners. You can have the code golf one-liner, which is, just for fun to see how short you can get things. But that doesn't mean, one-liners, there's a lot of very useful ones in APL. And actually just recently I have an example where I had a problem I had to solve in production. It was a parsing problem, and I had to figure out the nesting levels of parentheses. And Roger Huey has this excellent, on the JSoftware website, jsoftware.com/paper/50. That's a great introduction to what you could do with APL with 50 functions. And one of them, I think this is a very interesting story, is the 5th one, the parenthesis nesting. He talks about going to England. This is Alan Perlis, the first Turing Award winner. He's in this conference in England, and Don Knuth is invited, Ken Iverson is invited, and Ken is up there showing this one-liner. And it's to do this exact problem that I had. So this is, over 50 years ago, the same problem. And the solution is, you take the right argument, you have a character string, and you index that into an open and a closed parentheses, which results in, if we're in IO 1, 2, or 3 out of bounds, and then you take that and you index that into the integers 1, -1, and 0. And then to the left of that, you just do a plus scan. That's it. That's the whole solution to this problem. And Alan Perlis saw the magic of this. He's actually sitting next to Dijkstra on his right and Fritz Bauer on his left. And he exclaimed like, wow, that like, isn't there something to this or something along those lines? And Fritz Bauer on the left says, as long as I'm alive, APL will never be used in I think he was in Munich, Germany. And then Dijkstra chimes in, nor in Holland. So these are two. And then Perlis realized the magic of this expression. And then here I am in a production situation. I get to use this character for character as a solution, which is really cool. The cool thing about programming APL, I always think about programming being an ultimate balance of science and art. You know, there's the science to it. You got to write an optimal solution. You have to make sure, you know, run your performance tests, make sure everything's performing good. And then the artistic aspect is very important to me too. Your code should look beautiful. And I think Roger Huey was one of the greatest examples of this. If you look at his code he's written, and he was a big proponent of this as well. But then it also adds this kind of third dimension when you write APL code, is this historical dimension that I don't think many other languages have, that you could talk about. Oh, this, when you write a line of code, there's a whole bunch of history behind it. But these kind of expressions, they're short, and there's a whole bunch of them. I have a Finnish book of idioms that was given to me, of APL idioms. I don't know Finnish, but I could take a look at one of those expressions and understand exactly what it's doing. And maybe if I ever go to Finland, I'll use that as a Rosetta Stone, figure out some expressions. I don't know if that'll get me very far, but
it's funny you mentioned this parenthesis nesting. I mentioned in the beginning of the episode, they have this chat event going on every week, and this very last one, just this past Friday, was exactly on checking whether the parentheses were properly nested, balanced, and this exact expression, as you say, character for character, came up as one of the solutions. And I'll put in the show note link to the video that I have to make this week just about this problem.
Yeah, that's interesting, because I had that last month, and you can see how timeless these expressions are. And if you bloated this out into a bigger solution, it wouldn't be as general, and I don't think you'll have someone talking about it in 50 years that, you know, it serves a purpose.
Yeah, I don't think it was the exact solution that you said, but I one time made a leak code solution video with a bunch of languages and then showed how I thought APL was the best, and it was for the maximum depth of parentheses. And I think it had like 16 or 17 characters, and I had just written it on my own. And not recently, but at the time, I had also been reading APL papers and trying to just consume all the stuff. And I came across a paper from 1979 called Operators, where he's going through sort of scans and outer products and stuff. And he has a similar solution where he does an outer product with a 2-character string of the left parentheses and right parentheses, and does a plus scan and then a reduction at the end. And I'm reading this and I'm like, what the hell? Like, this is the leak code problem that I just solved 2 months ago. And here Ken Iverson, like literally like half a century ago, is like out leak coding me. And then so I made another video being like, you guys aren't going to believe this. Like, I solved this. It was 16 characters. And his solution is like, it's like 8 or 10 characters or something. And I think I'd heard the similar story that Dijkstra was just like, you know, this is an abomination. But like, you know, I don't know how you can stare at that code and not, even if you don't like the symbols and stuff, how can you not find that like just super beautiful? And while I'm saying this, Stephen is holding up his copy of the Finnish idiom booklet that he has. It looks like it's actually an original because it's bound. It's not like printed off and cut up. Where'd you get that, Stephen?
Oh my goodness, I wish I know. It's got genuine Finnish in too. All the comments are in Finnish.
And I think there is a PDF copy online. I've seen somewhere where you can get your hands on it. And there's a bunch of different great resources where like I've always wanted to. There's like, I think there's another one called 40 APL idioms, or it's something like, you know, that you must know, and or very common ones. And I've always wanted to go through, because a lot of these are written sort of decades ago without a lot of the newer glyphs and operators that Dialog APL has added. So I'm sure some of them will be identical, but I'm sure some of them you can probably, you know, half the number of characters, because, you know, Dialog APL today is, you know, I don't know if it's twice or 5 times or 10 times as more powerful than the APL of the 80s. But anyways, yeah, that's we should throw it back to John, or go ahead, Bob.
Well, I was just going to say, do you think these idioms or these really short programs last so many years because it's almost like degrees of freedom? When you're working with it, it's working so precisely with what you're trying to do. It would be hard to do something that didn't follow the same form, especially when you've got somebody who originally, originated the language, knows exactly how it is. They're more likely to use it with much more precision. Once you've seen that precision, it's almost hard to get away from that and write obfuscated code.
Yeah, that's an interesting thing. And I think that's one of the other reasons I really like the APL expressivity. The thing is, a lot of people talk about type systems and how APL, should have a type system. Aaron Suit does a great talk on this. And that's one of the benefits of having, you don't have types, you don't need to declare things, which allows you to have a very small solution that is general across different types too. That's very important to me. One of the most amazing things is the marriage between types in APL to solve problems, like the idea of there's no real distinction between a Boolean and an integer. You can use them you could do math on them. And that really helps you when you solve problems. You look at it a different way. The primitives are built to work across, a lot of them are built to work across types. Like there's no string.index of, there's just an iota, and then you can use that on, an array of characters, an array of integers, or whatever you have.
I wanted to respond to that timelessness of these small expressions. I mean, kind of mentioned dialog, especially having added lots of features, but most of what has been added is kind of plumbing around, interfacing with various things. The core language hasn't really developed a lot because it's this diamond. You add anything to it, you subtract from it. And if we look at the core vocabulary of APL or any of the array languages, really, every primitive represents this fundamental concept of transformation on arrays, everything being represented by arrays. And that doesn't really change much. You just have to have that vocabulary and you build things up from that. So these expressions, they're timeless because people still want to do the same type of work in what they do. And this is how you express them. These Lego blocks that are fundamental concepts of information transformation, you build them up like that. And even when we add a new primitive to do something that is commonly done, then it's just about taking the old expression and substituting some part of it that's now expressed more concisely or better with a new primitive, but it's still fundamentally the same algorithm. So these are, in fact, timeless expressions.
Yeah, I think there's points in times where you write a piece of APL code, I find, where it's just so there's only one way to write it. Technically there's two ways. There's the defun way and then there's the tacit way. And I always lean towards the tacit if it's, less than a certain number of glyphs. But even was it a couple days ago, I was solving a leak code problem that involved, checking whether one string was a prefix of another one. And there's a classic sort of idiom that uses a top, which is, a first of find or first a top find. So, it'll basically find anywhere that a string is a substring of it. And if you just check the first element, it'll say, well, was the string on the left, a substring of the other one. But you run into problems where what if the string on the left is longer than the string on the right? Then you end up with an empty list for the result of find. So I ended up coding another solution that basically does a take on the second string with the length of the first string. And if you end up in the situation where the string that you're checking, if it's a prefix, if that one's longer than your target string, it'll just basically the behavior of take, which I actually didn't discover for a while, adds the default value, which is a space for a string, to the end of it. So you end up with this basically, once again, I think in a top, where you have, or it's actually not in a top. It only exists in BQM, but you can spell it in APL differently, which it's before, which is sort of length before take. And it's sort of the flipped hook, I think, in J, and you can get it working by twisting some stuff in APL. But when I saw that, I was just like, it's three symbols. You've got length or tally or whatever it's called, and then before, and then take. And that's the thing, is in like Python or C++ or Java, you could spell that or write that, sort of many different ways. What are you calling the index on your loop? Just there, technically it's an infinite number of solutions, because sure, you could call it I, but you could also call it J, K, any number of things. Whereas there's no index, there's no looping. Like there's only one sort of pure way to spell that in BQN or APL or J. And it's like once you see that, you're never going to write that mini expression any other way. And there's so many of those small idioms. Once you see the average, which I think is the first of the 50 functions that Roger Huey does in that paper you mentioned, Josh. And once you see that in sort of the fork form, you're never going to write average a different way, or at least I don't know. That's the way a lot of the idioms sort of impact me. Like you see it once, and it's like, oh yeah, that's clearly the best way, and sort of almost the only way, the right way to do that. I'm not sure if people have the same sort of impression when they see certain idioms. Bob?
Well, one of the things you mentioned starting off is there's two ways to do it. One is, the direct definition. The other is tacit. I wonder, how is tacit regarded in industry? Like, to me, it would seem to be good in some sense, some senses. In other ways, you probably want to stay away from it because it becomes wizard work for the rest of the programmers.
Well, so there's two questions for Josh here. What does Josh think, and what does industry think? Or even maybe three, what does like the Carlisle Group think, what does Josh think, and what does industry think? Because they could all be different.
Yeah, that's interesting. It's funny, the first person I saw to use tacit in a production environment, well, a big tacit expression was this newer programmer who didn't really know much APL. And then I was looking at some of his code he was doing, and I noticed this very complicated tacit expression. And this guy didn't know much APL. And I was like, hey, this looks like something Adám would write. And then sure enough, I copied it, and I go to Apple Cart, and it worked, that it came up there. So thanks to Adám, we are now starting to see it in production. But there's a lot of different types of tacit functions, I think. Like you mentioned the average one. That's my favorite tacit function, is the split one. And that is one that I think just makes a lot of sense as a tacit representation. It's, not equal, partition, right, or same. So that's something I find I've used that a lot. I use that a lot in production systems. But I do find, even not only just for tacit, like if you took a long tacit expression, would I put that in production code? No, but I probably wouldn't even put that as a defun either. It might be more, I think at a certain level, you shouldn't be shy of just breaking up your function into smaller parts. Or if you name it correctly, then I don't even have to open the function, and I don't care what's in it. So if it's abstracted that way. But yeah, I mean, tacit, I don't use them that much. I use defuns pretty much for everything. And I mean, there's even traditional APL functions, which I don't know if you've had much experience with them, procedural functions, which is another style of writing them, which is probably the over 95% of what you'll see in production APL systems, if you don't work at the Carlisle Group, which uses defuns for everything.
Do you run into limitations? Because I think I discovered at one point when you use defuns, you can't use, I think the if control flow statements, and then I'm not sure if it's the looping as well. Not that, I mean, you're always trying to avoid loops, but there's certain cases where, I don't know, it's if you're trying to, the classic I can think of is like the guessing game, guess a number between 1 and 100, and you're just cycling through, like reading in from the screen. I don't think you can use that stuff in defuns Do you find there's limitations, or basically there's a different way? Anything that you can do with a trad fund, you can find a way to do with a defund. It's just spelt slightly differently. Or?
Yeah, I think you could do everything with a defund besides some stuff like nuladic functions, which I don't even know if are a good idea anyways. A function that takes no arguments, which you can't do in a defund. But and also this is something Paul taught me, is if you need a block of an if statement, if your code needs an if block, then your function's too long. That should be a separate function. And you can do, we have guards in defunds to evaluate Boolean expression on the left. If it's true, then something on the right. But I try not to even use that as much. Sometimes you have to, but the whole idea of using Booleans, the APL way of doing a conditional is you can take a Boolean expression, and that also works as an index. You could pick a result based on that Boolean, which I think is a lot of times a nice way. The other thing is the power operator is another way to evaluate conditionals. This is one of my favorite operators, because one of the things I look for in a programming language too is how orthogonal it is. And that's a strong suit of APL, I think. You learn one function that it could be applied to so many different operators. Like you learn plus scan, and then, maybe I'll put a max here, and max scan works, max reduction, and so on. But back to the power operator. Yeah, I mean, the idea of raising a function to the 0th power means you don't run this function. So you could use that as a Boolean thing. Raise it to the 1st power, run it once, or you can raise it to the 2nd or more, and you're running the function that many times and passing in the result of the previous run in. And then on top of that, there's the negative power, which I actually got to use very recently in production code, doing some unit conversions, which is very nice. I used tacit for that. That was probably the first time I really used tacit functions, because you have to define functions tacitly to be able to use the inverse operator on them. Another interesting thing about the power operator, I think Roger Huey last year had a sort of pseudo serious question about maybe what does it mean to raise a function to a fractional power. So that's not something implemented yet. I don't know, maybe your listeners or you guys might have an interesting idea on that, but that's an interesting problem to think of.
So it sounds like a lot of the times too, then the answer to, can I do this a certain way, is like, maybe think about the problem differently. And there's a better array solution to whatever problem that whatever solution you're trying to bend into a defund that might not look like it fits. Potentially there's a different array solution to that I just haven't discovered, or you haven't discovered.
And, a lot of it, Adám showed this a lot too in some of his talks, is you could take, if you have a 0 or a 1 and you're not thinking of that as a Boolean, you're thinking of it as, in math, you could multiply that by a number to get rid of it, or, if it's 1, you keep the number. So you could do a lot of conditional expressions just by using pure math, instead of having to rely on these type of conditional statements that, you get into branch prediction and then can really slow your program down.
Yeah, that's a really nice pattern the first time I saw it, when usually in a functional language, you'll probably, filter some list before doing a reduction on it and summing things up. But in APL, you can just multiply the mask by it instead of filtering, and the masks will correspond to 1s being the things you want to keep and 0s you don't. So you can just zero things out basically and then sum it up. And I think that actually tends to be more performant in some cases, because you're not reallocating like an unknown sized array, which is really nice.
Also, modern day processors can use vector instructions, so it doesn't actually matter for the runtime, for within certain limits, of course, how much data you're processing. It takes the same time to go through the processor, but branch prediction failures, they take time.
One of the other questions, I feel like we're skipping around here a bit, but one of the other questions I wanted to ask is, so you went to university and got a CS degree, but after having sort of discovered APL at a very young age, and not only discovering it, but doing internships, I think you mentioned in high school, And so you'd actually had like a non-trivial amount of experience with APL before going into getting a university degree. And then while you were there, it sounds like you learned a bunch of different languages, all sort of Algol or Java-like. Do you have anything to comment on like how that experience of having learned APL from a young age, how that informed sort of going through university? Like the whole time were you just sort of scratching your head being like, it seems like we're going backwards here? Or were you trying to convince your classmates of like, hey, try to check this out, and people just looked at you? Or was it just something that you like was a big secret and that no one knew that you sort of had this, not alter ego like Superman or whatever, but just like, no one ever knew that you used to code in APL, and the reason you were finishing your homework faster was unknown to people? Or is there anything to say there, I guess?
Yeah, that's, no, I'm actually known as the APL guy in with a lot of my classmates, rooms. And the professors knew it too, and they were kind of interested. In our programming languages course, I got to go up when APL actually comes up in the textbook, so I get to go up and do a demonstration of it. I got to do some of my projects in APL too. But yeah, I'm happy I got to have that experience of learning, more low-level languages too than APL. It makes you more thankful for it, but also you do learn some tricks in a traditional CS degree that, I don't think it's always you have to have a completely APL solution to a problem. There's a lot of it's really good to go through that thing and learn about what is big O notation? How do I measure how this program's going to perform or scale? And learning these other data structures too are interesting, but at a certain point, I don't want to, I get tired of, we have to implement all the data structures at a low level, like linked lists, hash maps, and so on. But I'd rather spend my time focusing on one data type, which is the array that all these data types are really built off of. So I think it paid off more to just focus on that and just really focus on the APL set of primitives. But the CS degree, yeah, I like it, and I still use some techniques for that in programming. There's a lot of, I don't think there's a problem you can't solve in APL if it's solvable. There's some problems you just can't solve in any language, but it'd be interesting to see. I don't know if your listeners disagree that there are some say you can't use APL to solve a problem. Maybe email me firstname@dialog.com, and I'd like to take a look at those problems. And because there's other stuff in APL too, like we don't even talk about the idea of namespaces, which was very interesting, introduced by Ron Murray. He now works on the interpreter in Dialog internally. So that concept, you could do a lot of kind of CSE tricks that you see, like we talked about Abacus, that library for having a virtual APL DOM to represent what's going on in the HTML engine. But one of that key things is you can represent those elements as an array of namespaces. So you can keep track of things like having pointers to parents or other things like that. But there's a lot, it doesn't all have to be a simple 2D matrix. There's a lot of different ways to represent problems.
Did the CS degree widening of experience, I guess is maybe the way I look at it, does that help when you're actually looking at a production problem that it gives you a way to maybe look at how you might break down a problem as it's presented to you, and then almost use the APL as little nuggets embedded to solve the variety of problems that come up? You've sort of broken them down, as you say, into functions, and then the functions can be quite terse APL expressions, but the way they link together is actually maybe also related back to what you would learn in a computer science course.
Yeah. I mean, problems are, when you have real world problems, there's all different types of them. Some of them, can just be solved the whole operation at a time, array based. Some of them, you there's nothing stopping you from mix and matching these problems, using some more traditional CS approaches, but then it's all, that's the nice thing about dialogue is it lets you have the freedom to work with all these different paradigms. You could take a functional approach, you could take an object-oriented approach, and I'm commonly mix and matching different techniques, array-based or other ones that you might have picked up in CS class. But I think that certainly helps, but sometimes it can hurt you more than it helps sometimes, because if in the end, I think if you can think purely array-based, that will give you the best result, in terms of performance and efficiency too. A lot of times you fundamentally change how the problem solved, and it might be interesting to see a resurgence of this. I know now we're seeing the push to cloud environments where people are very cautious of how efficient or how many CPU cycles it takes to perform this problem, because now there's a dollar amount to it. So I think that might be an interesting area where you might see APL rise up again, because sometimes you could just express a problem without all this without having all this boilerplate stuff. You get to see the problem more clear.
All right, so we are a little bit over time, I think, but I guess maybe, well, first I'll ask, are there any final questions from the other three panelists before I co-opt the last question, ultimately for myself? But so, and this is sort of an open-ended question, but I'm interested if there's like a question that we haven't asked or something that you want to talk about. That it's just I've sort of gotten the sense throughout this conversation that there's been a couple times where you said, we could definitely dive a bit deeper, and so it seems like you've sort of definitely viewed opinions or formed opinions on whether it's one-liners versus production, or taking the way you think about problems and solving problems in array languages, and then using that to solve problems in non-array languages like Java. So I want to make sure that there's not a question that we haven't asked or something that you want to say, whether that's just with respect to APL or programming in general, because I find it super fascinating that from a very young age you managed to discover APL, whereas I didn't really discover it until much, much later in life. And you've basically turned your whole career so far. Like you've worked at a couple different places, and now you're consulting and full-time developing an APL. And from my point of view, that's like, wow, like that's like, what did I do differently other than not having a neighbor? So I'm not sure if there's like wisdom to impart, or I'm sure there's a few listeners that are younger and might be thinking, oh yeah, I'd love to work in with APL, but there's way more opportunities writing Python out there. So anyways, that was sort of a super open-ended, long-winded ramble, but feel free to respond however you want to.
I think that story that I had a neighbor who introduced me to APL just kind of shows that it's easy to get people into APL. It's easier than we think. So which is why I'm happy we have all this sort of media work that you guys are doing and Adám is doing and Richard, that I think people just need to be introduced to it, because the nice thing about it is people don't realize that they've been learning APL their whole life without knowing it. When you take math class as a kid, you're learning it. And then there's really not that much to learn to it. And it's an optimized learning. Like if you learn take, by virtue of knowing that, you now know what drop does. And again, the orthogonal aspect of it, things you can, with a small set of primitives, and operators especially, you can mix and match them in ways that just make sense, that you'd expect. For me, I really, really like working with APL because it's basically solving puzzles all day. So it's really fun, and I'm happy I get to do it. And there are opportunities out there for people who want to do APL. Especially our age, because you had a lot of older folks who are now near retirement who have been working on these APL systems. So there are openings for this type of work. And even if you don't want to I think there's a lot of smart minds I'm seeing in the Orchard and all these places, these young people looking at APL. And I think that don't be afraid to apply it to build something, because that's what I've seen. I've seen a lot of small groups, people just take an idea and just run with it. And APL really holds your hand the whole way when you need to build something amazing.
Well, I think that's a perfect way to end it. If you want to have fun all day long solving problems and have your hand held, and also not have to be confused about what public static void main means, check out APL and build a career out of it. If Josh did, I guess anyone can. And you don't need a neighbor, I think. I guess maybe time will tell. Watch as, 4 of our next 10 guests also were neighbors with some prolific member. Then I'm just going to start to get a bit disheartened.
Yeah. I did figure out what public static void meant by the time I finished my career.
Well, there you go.
My CS career in college. So,
Bob, you were going to say something?
I was just going to add the usual, if you'd like to get in touch with us, it's contact@arraycast.com, and you can send emails there, and we respond to them. We've had some really good suggestions, and upcoming shows should reflect some of that, although every time we do a show, Connor seems to come up with a few new people that we really should have on, and he's absolutely right, but it does tend to expand the the list of, we should have this person on, or we should do this topic. But still, that's the way you get in touch with us, contact@arraycast.com. And show notes have been mentioned throughout the show, and they are, I think, vital if you're at all interested in what we're talking about. Quite often the show notes go into much more depth and really give you an understanding about some of the concepts. So if you get a chance, show notes, and also we have transcripts of the whole thing, so that if that's useful to you, for whatever reason, searches, it's great. You do a search on a topic, and bang, you can find the part of the episode that relates to it. So I think that's about it for me.
Yeah, I think our guest list is going to be like, everyone's book list. You finish one book, and then unfortunately that book mentions 4 other books that you have to add to your list to read, and book lists don't ever get shorter. Incrementally for one moment you'll subtract 1, but in aggregate they're just constantly growing. So I'm pretty sure that's going to be the same thing with our guest list. Plus, when you mentioned that we're really bringing everyone back at some point in the future, it's a losing battle. But yeah, Josh, thank you so much for coming on and sharing your story. And I think it's pretty inspiring, and it's also super interesting because I don't think we've really had anyone on the show talk about writing production code in APL. We sort of talked a lot about the philosophy, personal stories, but not so much, how do you go from writing one-liners and the difference between the different types, and then, just different problems that, all software engineers are solving. But this is, I think, sort of the first time I'm hearing it on this podcast. So it's super interesting to hear, and we'll definitely make sure to link, all the talks that we mentioned about you winning your APL contest. Maybe we'll have you back on. Maybe we'll have like a past contest winners at some point, and we'll bring a panel of all them on, and we'll do something special like that. And we'll also make sure we get your socials, so if people want to follow you, that they definitely can. So thanks for coming on. And with that, we will say happy array programming.
Happy
Happy
array
array
programming.
programming.